Hi. I hope you can hear me. We are going to continue with the course. Today we are going to look at problem 26 onwards. This is the first problem. The question says, find all functions from R star to R such that f of 2016 by x is equal to 1 minus x times f of x for all x belonging to R star. Here, when I say R star, it means real numbers excluding 0. So any real number is in the domain except 0. And the function is from this R star set to the set of R. And this is the functional equation that we have that we need to solve. So try it out. See if you can figure out what to do here.
Yeah. 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 तेरी तरह नहीं मैं भी छोड़ कर दूंगा
You have
वो
to
देखा
mute
गया है
yourself. This type of functional equation, usually you have to do some sort of a substitution. And if you do the right substitution, you could be able to solve the question. Mostly this involves a little bit of guesswork and experience. Here the function is from real numbers, so it doesn't make sense to input any integers. It's not an integer function, integer valued function. It's a real number function. So you have to think of what substitutions you can put. If there is a nice substitution that will help us solve this question.
So can we substitute 216 upon x instead of x? So it will be linear equation.
Right. That is the correct idea. Instead of x, everywhere you will put 2016 by x. If you do this, what will happen is the left-hand side will become what? 2016 by 2016 by x is equal to 1 minus 2016 by x. And this is f of 2016 by x. Right?
Yes, sir.
Now, this equation is looking like f of x is equal to 1 minus 2016 by x multiplied by f of 2016 by x. And at this stage, you will use again this result only. How do you use it? We replace 2016 by x, f of 2016 by x with 1 minus x f of x, right? You can replace that here. So what you will get is f of x is equal to 1 minus 2016 by x multiplied by 1 minus x f of x. Right?
Yes, sir.
So this becomes 1 minus 2016 by x plus 2016 f of x is equal to f of x. And now you just solve it for f of x. So you end up getting 2015 f of x is equal to 2016 by x minus 1. So finally, our answer is f of x is 1 by 2015, 2016 by x minus 1. This is the function that satisfies this equation. I hope the method is clear. This is the key idea, the substitution, which changes the function and gets its reciprocal here. And then you use the original result into it once more, and you can solve for f of x after that. Okay, that was pretty easy only. Let's do another problem. Okay, solve in prime numbers the equation minimum of P and Q minus 1 by maximum of P and Q is equal to 1 plus 2016 by PQ. We have done several questions like this, so this should be clear to you. Last week, we have done several problems like this. Solve in prime numbers means our P and Q have to be prime.
Sir, is the answer P is equal to 1009 and Q is equal to 2?
That is one answer. The other option is also there.
Yes, sir. 2, 1009.
The way to do it is to assume P less than equal to Q without loss of generality, right? And then write it as the equation becomes P minus 1 by Q is equal to 1 plus 2016 by PQ. And if you simplify this a little bit with a little bit of cross multiplication and all, you will get P into PQ minus Q minus 1 is equal to 2016. Once you get this, you have to think of the odd and even nature, right?
Yes, sir.
Notice that PQ minus Q minus 1, what is it, even or odd? This is odd, always, unless P is 2. Think about it. If P is odd, this thing is odd, right? Correct?
Yes.
But if P is odd, then you'll have odd times odd, which will not be even, right?
Yes, sir.
Which means that P is even. That means that P is 2. We have seen this many times now. And once P is 2, you can find Q very easily. So I'll not discuss this too much. You have already done it, so there is no issue. Let's go to the next problem. Problem 28. Find the greatest negative integer n for which the equation x square plus nx plus 2016 equals 0 has integer solutions. Find the greatest negative integer n for which this equation has integer solutions.
सर -2017.
-2017. Why? How do you know it's the greatest negative integer?
Sir, because I've already done such kind of problems and every time I got कि जो बीच वाले रूट्स होते हैं उनका सम हमेशा 2016 से छोटा ही होगा, चाहे कुछ भी हो जाए.
Tell me what you have done. Explain.
सर हम बेसिकली 2016 को फैक्टराइज करके देखेंगे और हम ये पैटर्न देखेंगे कि 2016 टाइम्स 1 जो होगा वो अपने बाकी के जितने भी प्रोडक्ट होंगे, बाकी के जितने भी फैक्टर में हम इसे ब्रेक कर सकते हैं एज अ प्रोडक्ट ऑफ टू, उनसे ग्रेटर होगा 2016 + 1.
What you are saying is not correct. The answer is not correct.
सर करेक्ट नहीं है.
नहीं. इतनी जल्दी में रहोगे, हड़बड़ी में रहोगे तो करेक्ट नहीं होगा. तुमने पहले कोई क्वेश्चन किया है उसका मतलब ये नहीं है कि ये क्वेश्चन सेम है.
ओके सर.
How have you ensured that it has integer solutions? What is your logic for having integer solutions?
B square minus
लेटस
4AC should be square.
क्या क्या फिर से बोलो.
लेटस
N
फॉर्मूला से कर देंगे कि a+b जो होगा वो -n होगा और ab जो होगा वो 2016 होगा.
Okay, so
सो उसके बाद हम फैक्टर्स बना लेंगे 2016 के.
फैक्टर्स बनाने से क्या फायदा होगा?
सर मतलब हमें बेसिकली तो सम ही देखना है ना कि 2016 के फैक्टर्स में से अगर कौन से दो ऐसे फैक्टर्स है जिनका प्रोडक्ट 2016 है और सम सबसे ग्रेटेस्ट हो.
हाँ, सो सबसे ग्रेटेस्ट तुमको मैक्सिमाइज करना है किसी चीज को. उसमें केसेस लेके सारे केसेस चेक थोड़े करना है.
हाँ, वो तो हमें पता है ना कि जो नंबर इटसेल्फ है और टाइम्स 1 वही हमेशा ग्रेटेस्ट होता है.
ओ, ये पता है क्या? नंबर इटसेल्फ और टाइम्स वन हमेशा ग्रेटेस्ट होता है? किसने बोला ये?
टाइम्स 1 उसका सम हमेशा फैक्टर्स करेंगे तो उससे छोटे आते हैं ना. जैसे अगर हम इसको स्प्लिट करेंगे इंटू टू में 1008 इंटू टू लिखेंगे, उसका सम जो आएगा वो 1010 आएगा, मतलब माइ.
व्हाट
और
यू आर सेइंग इज
जबकि
इनकरेक्ट.
इसमें
जो तुम बोल रहे हो वो गलत है. थोड़ा और सोचो उस पर.
अच्छा ठीक है सर.
बिना
so we
कुछ. टेल मी, आराध्य.
so I guess we can do n like b square minus 4ac should
हम्म.
be perfect square. So n square minus 4 into 2016 should be I took it p square.
हम्म.
So n square minus p square is equal to 4 into 2016. So we it will help to like I'm solving it. So it can be factorized and solved.
If you assume that a and b are the integer roots we have from Vieta's relation, a plus b is -n and ab is 2016. Because we know that n is a negative integer, this -n is greater than 0.
Oh yes, sir. We can use Vita English.
What we have to do is we have to minimize A plus 2016 by A. Why do we have to minimize it? We need to find the greatest negative integer n. We have to
गलती
find
समझ गया.
गलती समझ गए तुम इतना जल्दी अस्यूम करके चल रहे हो तो गलती तो होगा ही. किसने
सॉरी
बोला
सर,
है
मैं
कि वो 1 इंटू
माइनस
होगा?
2017 को ग्रेटेस्ट समझ रहा था. सॉरी सर.
सॉरी, मुझे सॉरी बोलने से क्या होगा? मेरे लिए थोड़े कर रहे हो, अपना सोचो कि इतना हड़बड़ी में क्यों हो. हड़बड़ी में रहोगे तो गलती होगा ना फिर. पहले कोई क्वेश्चन किया है इसका मतलब ये थोड़ा है कि हर समय वही हो जाएगा. मुझे कोई सॉरी बोलने की जरूरत नहीं है, अपना सोचो कि कैसे इंप्रूव करोगे. डोंट बी इन सच अ रश.
Okay, sir. I'll try to first attempt the problem seriously.
देयर इज नो प्राइज फॉर बीइंग फास्ट. देयर इज अ प्राइज फॉर बीइंग करेक्ट.
Yes.
फास्ट होने से कोई फायदा नहीं है. We have to minimize this.
Yes,
Why
sir.
do we have to minimize it? Because we want the greatest negative integer, right? So greatest negative integer मतलब minus n. Basically, for which this equation has integer solutions. तो उस negative integer से बड़ा अगर integer होगा तो फिर हमारा integer solution नहीं आएगा, right? If there is, let's say the answer is 50, minus 50, then minus 49 should not give us integer solutions, right? Do you understand what I'm saying? If the greatest negative integer is minus 50 for satisfying the condition of the problem, then minus 49 should give us no integer solution, right? Which is the integer bigger than that. I hope everyone is understanding what I'm saying.
Yes, sir.
So therefore, notice that the absolute value 49 is lesser than 50. So we want to minimize the absolute value of A plus B, right? And B is 2016 by A. Correct?
Yes, sir.
So if this is a very simple A and GM, you can say A plus 2016 by A will be greater than equal to 2 times root of 2016. Right? And the equality will happen when both A and 2016 by A are equal. So A must be root of 2016 for equality to happen in this inequality. Right? If you calculate roughly root of 2016, this will come out to be something above 44, 44 point something, right? So we have to find the nearest integer which is close to this root 2016, which will minimize the value of this thing, right? Now you
Yes,
have
sir.
to do a little bit of trial and error. 44 के पास वाले कुछ देखना है. तो इसमें से देखोगे तो 42 और 48 का प्रोडक्ट होता है 2016. 44 के पास रखना है अपने A वैल्यूज को, A और B दोनों को. So the only way to do it where A and B are integers is 42 and 48 product. Because the overall value will be close to this then. And if you take 42 and 48, you are getting n is equal to minus 90. 42 and 48 are the roots, n is minus 90. And you can check that if you take n greater than or equal to minus 89, what will happen? Check the discriminant of the quadratic when n is greater than or equal to minus 89. The discriminant is becoming n square minus 4 times 2016 And my 89 square minus 4 times 2016 will become negative. You should check this. This will become negative, matlab no roots after that. Are you understanding what I'm doing?
Yes, sir.
अमन, तुमको समझ में आ रहा है?
यस सर, 89 पे रूट डिस्क्रिमिनेंट नेगेटिव आ रहा है तो समझ गया। और
90 पे हो रहा है, 90 पे रूट्स बन रहे हैं,
हाँ
उससे बड़े इंटीजर्स पे नहीं होगा।
हाँ
और ये कैसे आया, 90 कैसे आ गया अचानक?
हाँ, हमें क्योंकि वैल्यू पास रखनी थी ए और ए प्लस बी की, क्योंकि जो एक्चुअल मतलब जब दोनों को इक्वेट करेंगे तो 44 आ रहा है, तो मतलब हमें हमें जो रूट्स लेने हैं तो
हाँ,
44 के सराउंडिंग में होने चाहिए।
तभी वो इनइक्वालिटी के लोअर पॉइंट के आसपास होगा।
हाँ
इनइक्वालिटी का एग्जैक्टली इट इज नॉट गोइंग टू बी, बिकॉज इंटीजर वैल्यू चाहिए हम लोग को।
हाँ
If it was a real number, you could have said root 2016. I hope everybody is understanding what is happening. Okay, then we'll go to the next one. Uh, Question 29. If precisely one of the integers a, b, c, d is negative and a cube plus b cube plus c cube plus d cube plus 3abcd is equal to 2016. Find, one second. Find the maximum possible value of the negative integer. Question is a little bit of a mix of number theory and algebra. Think about what you will do. There is a nice trick in this problem. First of all, you have to realize that all the numbers are integers. All of them are integers. Only one of them can be negative. Right? And we have to find the maximum possible value of the negative integer. In general, if you don't think about the question, what is the maximum possible value of a negative integer? Which is the largest negative integer?
-1.
So for now, let's just see whether -1 पे कोई answer आ रहा है कि नहीं, whether -1 satisfies the problem or not, right? This is the largest possible negative integer, right?
Yes, sir.
So what we will say is we know that all the others are positive, right? If we assume D to be -1. We know according to the question, the others are positive integers. Correct?
Yes, sir.
So what happens if we try it? Let's try D is equal to -1 here. So it becomes A cube plus B cube plus C cube -1 minus 3ABC is equal to 2016, right? So this is becoming A cube plus B cube plus C cube minus 3ABC is equal to 2017, right?
Yes, sir.
I hope everyone knows how to factorize this.
Yes, sir.
You can write it as A plus B plus C, and you can write it as half of A minus B whole square plus B minus C whole square plus C minus A whole square, right? I hope you know this one, this thing.
Yes, sir.
So what we are getting is A plus B plus C times A minus B whole square plus B minus C whole square plus C minus A whole square is equal to 2 times of 2017, right? Correct.
Yes, sir.
Now think about it. 2017 is a prime number. 2 is also a prime number. You can check 2017 is prime. In order to check the primes, what do we have to check? How do I check whether it is a prime or not? How
सर
much?
स्क्वायर रूट लेके उससे छोटे जितने इंटीजर्स हैं उन्हें चेक कर लेते हैं.
उससे छोटे सारे इंटीजर्स नहीं, उससे छोटे प्राइम
अब सब
नंबर्स.
प्राइम नंबर्स. प्राइम नंबर्स.
Square root से छोटे वाले सारे prime numbers you have to check, right? So you can do that check. It is prime, I'm telling you. And if it is prime, and we know that A, B, C are integers, then this side, left side is a product of two integers, right? And right side is a product of two prime numbers. So that can only happen if the numbers are matching, no, somehow. There is no other way to write 2 times 2017 other than writing it in terms of prime numbers. Right?
Yes, sir.
I hope everybody is understanding what I'm saying, right?
Yes, sir.
You have to have either A plus B plus C is equal to 2 and the other thing is equal to 2017, or, but this is not possible because three integers positive cannot add up to 2, right? So this case is anyway rejected.
सर
That
बट ऐसा कहीं लिखा नहीं है कि वो नॉन नेगेटिव भी नहीं हो सकता, तो वो भी कंसीडर कर सकते हैं.
0, if you consider, then you could consider 0, but you can
सर
try all combinations with 0, but I don't think it will fit.
हाँ मतलब बट एक पॉसिबिलिटी वो हो सकती है शायद.
You can try the combinations with 0, it won't fit though. You can try it.
ओके सर.
You can take 1, 0, 2 non-zero. If 2 non-zero, the only option is 1 and 1, right?
यस.
But then you will see that it is never even close to 2017, the other side, right? These are very small integers. No, it can't be 2017. Do you understand what I'm saying?
Yes, sir.
It is impossible to satisfy this
Yes, sir.
also and this also. So the other option is the only option for us. This is the only option for us. And this is easy to solve actually, if you think about it. The sum of squares has to add up to 2. So the only way it can happen is if two of them are 1 and one of them is 0. Or two of them are 0 if you put, then it will never be, one of them will not be, square is not 2. There's no integer square which is equal to 2, right? The only way it can happen is 1, 1 and 0, something like this. I hope everybody is following what I'm saying.
Yes, sir.
Yes, sir.
Which means that the numbers will be, two numbers have to be equal, n, and one number has to be n plus 1, right? Then only this part will become equal to 2, right?
Yes, sir.
And if you do this, that two numbers are equal and one number is one higher than the other numbers, you will get here 3n plus 1 is equal to 2017. So 3n is 2016 and n is coming out to be 672, I think. Right, 672. And basically the three numbers becomes 672, 672 and 673. Right? Basically, we have found three integers which satisfy the conditions of the problem. And the fourth integer is d is equal to -1, right?
Yes, sir.
So why is this problem over right now? Why is it over? There could be other integers d which are smaller than -2 or -3, which could also satisfy, but we don't have to care about those, right? Because our job was to find the maximum possible value of negative integer. We have already checked the maximum negative integer, and in that case, we have found a solution for ABC also, right?
Sir, I have a doubt कि अगर d is equals to -1 satisfy नहीं करता तो हम क्या अप्रोच अपना सकते हैं?
तो फिर -2 पे चेक करते हैं. There is no easy way to solve this.
So, मतलब इसका कोई फैक्टराइज करने का तरीका नहीं है कि हम a जो एक्सप्रेशन दे रखी है हमें उसे कुछ फैक्टराइज कर सके.
There are four terms. This is asymmetric. No, there is no factorization happening with 4d cube, four terms which are cubes and one term here. फैक्टराइज करने के लिए ही तो d को कांस्टेंट लिखे थे ना, उसी से तो फैक्टराइज हुआ.
तो हमने डिग्री से ही बनाई है बेसिकली, एक को कुछ अज्यूम करके.
कुछ भी अस्यूम नहीं किए, ऐसा अस्यूम किए कि
-1 अज्यूम करके.
-1 अस्यूम इसलिए किए क्योंकि that is the highest negative integer. If we can get it in that, then that is the answer. If we had assumed -2 or something, and even if we had gotten a ABC satisfying it, still we would have to check -1, right? Do you understand what I'm saying? -1 check तो करना पड़ता ही ना finally.
हाँ.
Because -1 is the maximum possible value of the negative integer. Okay, hopefully you've understood. We'll move on.
Yes, sir.
Question 30. Find all real numbers x such that 4 power x minus 1 plus 7 power x plus 8 power x plus 9 power x divided by 4 whole to the power 4 is equal to 2016 power x. It's actually a very easy question, just a trick. There is a simple trick. So you don't have to be scared of the question. It's very easy actually.
सर 0 आ
Hmm. 0 is correct.
AMGM से।
Hmm. So the idea is actually this has been broken apart to just confuse you. If you take the whole thing as 4 common denominator, here it will become 4 power x, right? Aradhya, are you understanding what I'm saying?
Yes, sir.
And now if you think of this thing by AMGM, a plus b plus c plus d by 4 will be greater than equal to fourth root of ABCD, right? So
Yes,
if
sir.
you do ABCD 4 into 7 into 8 into 9, see what comes.
So 2016.
Hmm. So it is greater than equal to, this term inside is greater than equal to fourth root of 2016 power x, right?
Yes, sir.
So when you raise it to the power 4, it will become basically the whole left hand side is greater than equal to 2016 power x, right?
Yes, sir.
So how will you have the equality case?
When all the terms are equal, 4 to the power x is equal
Hmm.
to 4 to the power x.
All the terms under the AMGM have to be equal. So A is equal to B is equal to C is equal to D means X must be 0, right?
Yes, sir.
Okay. Problem 31. Okay. A cyclic quadrilateral with integer side lengths and area equal to 2 times square root of 2016 has an inscribed circle Find the perimeter. Find the perimeter of the quadrilateral. This question is homework for you guys. Today I have to end the class 10 minutes early. This question is homework. Write down the question. Notice that there are two important things in this question, that it is a cyclic quadrilateral and also that it has inscribed circle is there inside it. Inscribed circle means there is a circle inside the cyclic quadrilateral also, right?
Yes, sir. We can use Pitot theorem, I guess, in this question.
That is the main thing. So you need to know what is Pitot's theorem. If there is an inscribed circle inside a cyclic quadrilateral, the sum of opposite sides is equal, right? If this side is called A, B, C, D, Pitot's theorem says, which is a very easy theorem because length of tangent is same, right? I hope everybody is understanding what I'm saying.
Yes, sir.
The sum of opposite sides must be same in a quadrilateral that has an inscribed circle. Also, it's a cyclic quadrilateral and area is given, right? So you also have to use Brahmagupta's formula for cyclic quadrilaterals area. For area of cyclic quadrilateral. If you use Pitot's theorem along with this Brahmagupta's formula for area of cyclic quadrilateral, then the question boils down to an equation. After that, you can try and get the integer side lengths. I hope everybody is understanding what has to be done.
Yes, sir.
So try this out. This is the first thing that we'll discuss tomorrow, and then we'll go to more problems. This is homework for today, okay? And tomorrow we'll start with questions from 2017. So far, if you see so many problems at 2016, right? So many questions we have seen which has the number 2016, right? So those were questions designed in 2016. Now we'll move on to questions designed in 2017 from next class onwards. Everyone has written down the problem, right? This question.
Yes, sir.
Okay, so we'll continue tomorrow with problem 31. That's all for now. I'll see you guys tomorrow. Okay, fine.